So say goodbye to the F word, flaky no more. Selenium has a pretty industry reputation of being a really flaky tool, right? Tests will pass and then they'll fail, and then they'll pass and they'll fail. No one knows why, right? So you're running the same test in the same environment. So how do we get rid of flakiness? We're actually going to address 3 things today in this talk. So our whole goal is around maintainability, stability, and readability of your test cases. And it's going across the entire enterprise wide, right? So we're not talking about like how to fix one particular test or like make one thing go away. We're talking about how to create a framework that you can use at your organization that's going to drive all 3 of these things throughout every test every product team has throughout your entire company, right? So maintainability, stability, readability. Stability is where we're going to focus most of our time, but since all of these things kind of build upon each other, we're going to go through them one at a time. We'll start with maintainability. Hopefully no surprises here, right? The solution to maintainable Selenium code, use good locators, use PageObjects. These things have been around basically like since Selenium started. But again, because everything kind of builds upon each other, I'll just wanted to go through like really, really quick within a minute or two on a couple of slides. What do I mean when I say use good locators? What exactly are PageObjects, just to level set everybody's expectations? So what are good locators versus bad locators? Good locators are unique, descriptive, and unlikely to change. They need to meet all 3 of those criteria. If they meet all 3 of those criteria, they're a good locator. You can go ahead and use it. If any one of those checks fails, if it's not descriptive or it is likely to change, it's a bad locator. Don't use it. We don't want to go there. So here's an example of a bad locator. I'm sure we've all seen code like this in our Selenium test before. Some of you may have even written code like this before you knew better. So you have like driver.findElement. We have like some div and some span of some table of some tr, td, trow, right? So it's like by xpath //// like all the way down. The good news here it is unique, right? This is only going to map to one and only one thing, but it's not descriptive. Like who here can tell me what that's clicking on? No one? Yeah, I didn't think so. Yeah, it's an input somewhere, right? So this input like lives like over here on the page, and your test is working, and then all of a sudden like that input happens to move because like you removed a tr or a td or something like that, and now the input has gone from over here to over here, and all your tests are broken, right? So you lose your maintainability because you got to find every place that you've copied and pasted this code throughout all of your page objects, all of your tests. It's basically a maintenance nightmare. So what do we want to do? Just use better locators, right? Use things that are unique, descriptive, and unlikely to change. IDs are typically the best form of that. They're typically going to meet all 3 of those things. Now you may say, hey, Craig, I can't always use an ID for everything. Some things don't have IDs. Even better excuse would be sometimes my IDs are dynamically generated, so they're not necessarily going to be descriptive, and they may actually be likely to change if they're dynamically generated. In that case, it's OK to use other by locator strategies, right? Selenium gives us all these things by XPath, by CSS selector, by name. So you can use things like by XPath to actually produce a valid XPath solution that's unique, descriptive, and unlikely to change. Now, everyone can tell me what this code is doing, even though you can tell me what this code was doing before. So moving on, we go to our phase 2 of maintainability using PageObjects. PageObjects, I've found that when you use a construction similar to this, makes the code really readable, really understandable. Everything kind of flows together. So the first thing you want to do is have all of your by locators up at the top of the page. Notice we're actually using the by locators. We're not using like the page factory pattern where we have like at find bys and declaring web elements. We're actually using the by locators themselves. Next, you have your constructor. You'll notice here that we're calling super. This is because all the examples here are in Java, by the way. If you're familiar with another programming language, all the concepts are the same, so just bear with me. So here we're calling super. This is basically saying call something from the super class. And this is because every page object that we create across your entire enterprise, every project team, is going to be extending a base page implementation. We're going to get into exactly how that works. It's going to be the core to giving us our stability that we need. But just know, so like every time you have a constructor in any page object, you're always going to be calling super for the constructor of the base page implementation. Next, we have our isLoaded method, right? So this is typically going to be implemented by calling one of our base page implementation methods called isDisplayed, which, as you can pretty much guess, is going to say, hey, if the company logo shows up, in this case within 10 seconds, then I know that my page is actually loaded and rendered on the browser, and I'm ready to go. I'm actually able to use the example page object that I have here because it's ready to go on the browser. If the company logo was not displayed within 10 seconds, then you know that your browser is actually on some other page object and you're not ready to go. You want to throw some kind of error or exception and let the test know in a nice, clean way that you need to do something else. Last but not least, everything in a page object, the whole reason for the page object should be to have action methods that correlate to the things that the user can do on your particular page. So that goes at the bottom. So we've been mentioned just a little bit about this base page object and what it is and what it's going to do and what it's going to have. So let's go into a little bit more detail. The first thing that you want your base page object to do is actually encapsulate all of the Selenium commands. So what that means is anytime that you would normally do something like driver.whatever or webelement.whatever, so all of your driver.gets, your driver.get current URLs, your webelement.clicks and isDisplays and driver.findElements, all of those things, you're going to want to implement your own corporate method to how that stuff works in a base page so that you're not actually using any Selenium commands in your page objects themselves, and you're not using any Selenium commands in your tests themselves. All the Selenium commands get implemented in a base page down here, and then your page objects can call from the base page, and your tests can call from your page objects, and everything kind of flows that way. There's some really great benefits that this gives us, which I'll go into in the following slide. Just know that that's number one for what you want to use for your base pages. Number two is basically utilizing it as a way that you can actually implement core functionality that you're going to want to share across your company. Right? So let's say your company does a lot of work with HTML tables. You may want to implement a method like getCellFromTable containing text, where you pass in some table identifier and some text, and maybe this particular method returns the web element of the actual table cell within the table so that you can then interact with it, maybe click on a link or an input or something like that within that particular cell of the table. This next one here is select WYSIWYDGET value. This is basically a fictional term that I made up for each of your individual fictional things that you're going to run into at your company. Right? Maybe you guys implement some kind of like iPhone-like slider bar, or there's some drag and drop functionality, or there's a drop-down that's really not an HTML select drop-down. It's really like an element in an element in an element in an element, and like that's how it looks all pretty on the page. So all of your teams across your entire company are going to want to implement like, how do I actually do this slider bar or do this drag and drop stuff? And rather than each individual team implementing that stuff on their own, you can have one team implement it, throw it in your base page object, and then share that implementation across your entire organization. So you get a lot more maintainability that way. So now that we're all familiar with locators and page objects and we have our maintainability down, I wanted to throw this slide in here because maintainability is great, stability is great, readability is great. This is actually a bonus slide. So not only do you get those three things when you implement a base page object pattern like this, you actually get 4 other bonuses that are so big that I felt like they needed their own slide just to point them out to you guys. So the first thing that you get is encapsulation of all Selenium commands. So again, what we're doing here is anytime you're doing a Selenium command, driver.something, webelement.something, you have a base page method that's handling that particular logic. None of that logic is in your page objects, and none of that object logic is in your tests. So let's say Selenium decided to come along and change up their API, right? We're Selenium, we're going to create breaking changes for everybody. Rather than all of your project teams across your entire organization going through all their page objects, all their tests, and trying to fix those breaking changes that the Selenium team has put into their new API, we can go into our base page and change it in one place and one place only. And then all of your project teams, there's no changes you need to make to any of your page objects or any of your tests. So this is a really awesome way of giving us a lot of insurance, just in case the Selenium API ever changes. For those of you that are saying that'll never happen, who here remembers the old days with Selenium RC, right? We went from Selenium RC, we changed to Selenium WebDriver. It was rumored that Google spent like millions of developer hours changing thousands of tests that they had written in Selenium RC over to Selenium WebDriver, where if they had something like a base page implementation, they would have been able to make those changes all in one class. The next thing we already kind of talked about, right? We actually auto-enable functionality across the entire organization. So when one team implements the select WYSI widget and they throw it in the base page implementation, all the other teams are able to select WYSI widget for free. This next one kind of goes unnoticed, and it really can't be overstated just how powerful something like this can be. We're actually driving all the code that all the teams are using through our implementations in the base page. And what that gives us is a really great place to implement all the null checks we want to do, the fail safes. We can error out gracefully and throw lots of debug information out to the user saying like, hey, your test case failed, but like here's all this awesome information to figure out how you can fix it. And I'll go through an example in a slide or two that really demonstrate just how powerful this particular benefit can be. And last but not least, who here has ever found themselves struggling with a no such element exception or a stale element reference exception before? I'm sure we've all, like this is like the bane of my existence 5 years ago. But with utilizing a base page implementation like this, like you actually never see those errors ever again. Because we're actually only utilizing the by locators right when we need them in real time, not before, not after. So like those errors you never see anymore. It's awesome. So we talked about the base page implementation, what kind of methods and stuff it has in there. Here's some example of a minimalistic view of how it looks. Right, so we've actually removed all like the Selenium core commands and all the corporate specific examples. But this is basically what we're talking about. So every single page object is going to extend or inherit from our Selenium base page impl. And the base page impl has this abstract method here for isLoaded, which guarantees that every example page object, every page object that extends Selenium base page has to implement this isLoaded method, right? We saw that before. It's typically going to be implemented with like isDisplayed of some key element within some amount of time, maybe 3 or 4 seconds. But because we have this guarantee, what we can do is actually utilize that isLoaded method within our base page implementation constructor to give us one of the 2 key things that we need to give us our stability that's going to affect across our entire organization. And that is to actually check in the constructor itself if the page is loaded, and if it's not loaded, actually throw a new page navigation exception. So this is just a custom exception that I kind of created at Vanguard. It does some really nice, useful things like take a screenshot and call the name of the screenshot, whatever you pass in the message here. So if the example page object was ever determined not to be loaded when we tried to instantiate a new one, we would actually get a screenshot and say, hey, example page object is not loaded. By the way, here's what was, so you can have a better idea of what was going on with your test. Now, that's a much better example of something that a developer is going to want when a test case fails, as opposed to like no such element exception when the test kind of continued and tried to click the continue button on the example page, but the continue button wasn't there, and you're going to be like, well, why? What was going on? So we actually get a screenshot and stop the test in its tracks because we know that the page that we were expecting is not loaded, and we don't want to continue along with the test itself. So in addition to that, I kept talking about the core wrapper methods and how you want to wrap the Selenium commands within the base page. So I have here an example of one way that we can do that. So find element is kind of the end-all, be-all. It's like the one thing you would ever want to do with Selenium, right? Everything routes through find element, because the whole key is to find an element and then interact with it in some particular way. So through Java, we can actually overload our methods, right? So we have 2 find elements, one with just the locator, one with a locator and a max wait time. So if you don't pass the max wait time, we say 0, and it basically like find the element instantaneously. Otherwise, we're going to return null if the element doesn't exist. So going back to our bonus slide, right, I mentioned that one of the core benefits, because we know that every action that every page object across our entire organization is doing is all going to be calling like find element at one point or another every time it does an action. And so we can actually do some really useful things like null checking and other types of like graceful failures so that we can print out some really useful information to users if they happen to fall into some of these traps. Right? So if you can imagine like our find element, if we had this method just simply returning driver.findElement with by locator and the driver object itself was null, we'd get like test case blow up, null pointer exception. That's like super useful to a developer, right? Great. I got to go debug like what object was null, why was it null, how do I fix it? If instead we do some kind of check that says, hey, if driver equals null, let's print out a whole bunch of useful information to the developer, right? Let's say, hey, your driver was null. We were trying to do a find element on this particular page. Driver was null on that particular page. Here are the most common reasons for why driver might be null, and here are the most common fixes for fixing the driver object being null so it won't be null in the future. Right? Like that's much more useful than like null pointer exception test case blow up. So we go through our checks first, and then you can see like we're just instantiating web element equals null. If and only if the web element is determined to be enabled within some amount of wait time, then and only then do we do the Selenium command for actually finding the element and then returning it. If the element is never determined to be enabled, then we just end up returning null. And whatever method is going to call find element can deal with that null value however it decides to deal with it later. We'll get to some examples of that next slide. So this is really cool. Being able to throw in like some nice, pretty debug logic, pretty awesome. But what happens if I actually change this method to do something even more awesome? What if I threw a check like that in there? So you can imagine this isInvalid locator method implemented however you want to implement it within your company. One potential implementation might be, remember that bad locator that we had at the beginning of the slides, right? Driver.findElement of like this div and span and tr and td and body, right? All through by XPath. So what if we had an isInvalid locator method implementation that said if you're deciding to use by.xpath as your locator strategy, and your expression has more than 3 slashes, automatically fail the test. I don't even want to go further. Like we're just not even going to allow you to do that. So you can actually enforce good programming standards across your entire organization. Because remember, every single page object, whenever it tries to do anything, is all going to be calling this find element method. So by running some kind of check like this, you're actually verifying that all your locators across your entire organization meet whatever valid criteria you're setting for your particular organization there. Last but not least on this slide, we're going to get back to this isElement enabled within wait time. That's really the second key pillar to giving us our stability, right? It's how we're going to do our wait conditions. So just remember this particular method. We're going to get back to it after we revisit one more slide to talk about how find element is actually used in some of our other base page implementation methods. Right, so here I have an example. We have click, and we have this thing that I call type, which is just replacing the send keys command from Selenium. Right, so I mentioned before, every action that every page object ever takes, no matter what it's doing, is going to be calling find element more than likely through one way or another. So here we have just a couple more examples of some more implementation methods that you might find in your base page. Right, so we have click and we have type. They both are calling find element and then saying, hey, if the element that returned value is null, meaning that the element was never enabled to be enacted with, then we're going to do something like log error for not finding the element. Now again, this method can be implemented however you want within your company. You can very easily make it say something like, hey, we tried to find this particular locator on this particular page because we wanted to try to click it, but the element wasn't found. Oh, by the way, here's a screenshot of what the page actually looked like. Right, so you get a lot of really good, useful information out to your developers for if and when test cases fail. And again, from these two examples, you could kind of extrapolate how all the rest of the Selenium core methods would need to be wrapped and implemented for your particular organization. So we mentioned we'd get back to this particular method from before. This was, again, where we were calling from find element. Basically, what you want to do is just use explicit waits. There have been a couple of other talks that have mentioned wait strategies here today. Don't ever do thread.sleep, like ever, ever, ever. Implicit waits, I would personally argue, are almost just as bad. Just use explicit waits. You'll thank yourself later. It's really the thing, the second key to giving us our stability, right? So the first thing was verifying that all the pages are loaded before we actually want to try to interact with them. And the second thing is making sure that you use explicit waits for everything that you do, right? So you may have a link that's on a page that's always static. It's always going to be there. And so for that, you could say like explicit wait for 0 seconds. Like I'm always expecting that link to show up as soon as I know that I'm on the right page. as opposed to like there may be a continue button that's on a page that only becomes enabled after a form is correctly filled out first beforehand, right? So in that case, I may have some method that says, hey, fill out the form, here's a bunch of information. Oh, and by the way, now click this particular continue button, but wait for up to 2 seconds for that continue button to become enabled because like the front end has to verify that all the data got updated correctly before that button is going to become enabled for you to actually click on it. As opposed to some other method might be, maybe you're in the middle of a wizard flow and you're going continue, 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 and in the middle of one of the flows, you actually have to like process a batch job or something like that behind the scenes, right? So this next continue button isn't going to become enabled for 20 or 30 seconds because there's got a lot of processing behind it, right? So you have 3 different instances there, all of them taking different locator times or different max wait times. And so by setting the proper max wait time on each and every instance of each and every locator that you're going to want to use, that along with making sure that your pages are loaded before you try to use them are the 2 things that are going to give us the stability that we want, again, across our entire enterprise, across every single project team that we have. So now that we've gotten our stability, we've gotten our maintainability, and we've even gotten our bonuses, the last thing to talk about is really the readability. And where this comes in, there's again, I've been working on the Vanguard framework that we use across all of our tests, hundreds of developers, thousands of Selenium tests. And I've kind of come across a couple of rules that really help out on the maintainability, stability, and readability, really. But they're kind of core to the readability aspect of it. And that is that page objects do 2 things and 2 things only, and tests do 2 things and 2 things only. Page objects contain all the locators that you're going to want to use from within that page. And they contain any action methods that the user might actually take on the page. And tests can either assert things, or they can make calls to page objects to kind of like further along the test, right? Like page.filloutForm or page.continue, things of that nature. Notice that I did not say that pages can do asserts because they can't. And I did not say that tests should have locators because they shouldn't, right? So locators belong in page objects, asserts belong in tests. And if you follow these guidelines, you'll see that things get really, really readable. They're really, really understandable. And we have just enough time to kind of put all this stuff together and go through a couple of real-world examples, or close enough to real-world examples for how things would actually look in close enough to the real world. So we have our shopping homepage here. Right? We've got a couple of locators. We got one main thing that this particular page can do called navigate here. Where we're going to visit some fictitious URL. Please don't try to go to that URL on your own. It's completely made up for demo purposes. And then the last thing that we're going to do with this navigate here method is basically check, hey, is this thing loaded? If it is, we can return a new instance. If it's not, after we've tried to visit the URL, and if the search bar isn't loaded within 3 seconds, then throw some page navigation exception, throwing some screenshot and some nice lovely error messages to say, like, we were expecting to be on our shopping homepage, but we're not. And here's what was loaded instead. So because shopping home is a little bit long, not everything would fit on one slide. So we have another thing that shopping home can do. This is just kind of a continuation of the same exact class. We can buy an item, right, where we're passing in an item name and then typing in that item name into the search bar, clicking that item name from within our filtered item list, clicking the purchase button, and returning a new instance of the buy item page. Now remember, because buy item page, as we can see here, is going to extend our Selenium Base Page impl. So remember, that constructor is going to actually verify that we're on the buy item page before we exit out of this method. And if we're not on the buy item page before we exit out of this method, we're going to throw a new page navigation exception. So we're always verifying that we're on the right page so that we can use the page objects for that page before we actually use them. Right, so here's what buy item page actually looks like. We have, again, our constructor is loaded. There are a few things that buy item can do. We can query the page to get some state about it, right? So we can say, hey, is the item that I'm trying to buy the correct item? Is the amount the correct amount? And then last but not least, we can actually submit the purchase and go to the confirmation page. Confirmation page looks really similar to buy item. We can also verify that the item that we have now purchased is the correct one, that the amount that we purchased it for is the correct amount. And last but not least, we can log the confirmation number. So instead of a manual tester kind of like writing it down on a piece of paper, we can send it out to the sysout or database or however we want to implement log the confirmation number. So as you can see here from the page objects, right, there's no reference to any Selenium commands themselves because those are all encapsulated within the base page implementations, right? So the only Selenium-like commands we have are like get text and is displayed. And if we go back from before, we have like click and type, right? So those are all encapsulated. Those are all implementation methods that we've done in our base page. But our page objects themselves, no Selenium commands. Likewise, with our tests, they're going to follow suit with the same kind of thing. Just like we have a base page object, I highly recommend setting up some form of base test class. Kind of too much to talk about in one 30-minute session, but maybe another talk for another day. You can very easily imagine yourselves like, maybe I don't always want a Firefox instance. Maybe I want Chrome or Firefox or IE or Android or iOS. And if you have, especially like a company like Sauce Labs that's going to do all that nice stuff for you, you may want to do something that'll implement those things through properties files or annotations that you could tag at every single test. And that's the kind of stuff that would go into like a Selenium-based test implementation. For our minimalistic purposes here for a demo, we're just basically saying, hey, we have an instance of driver. We're going to launch a driver before every test. We're going to close the driver after every test. So no project team anywhere in our company needs to deal with launching or closing browsers because it's all done at the base test. So all you have to do is extend Selenium base test. You don't have to worry about any of that stuff. Also, likewise, here in our shopping test, we're setting up another setup method in app before saying, hey, I know I already have a browser launched, but I want to make sure that before I start any test within this class, that we're actually on the page for our application under test. So we're going to navigate here, and we're going to have that instance in our shopping home. So at the very first line of every single test case in this class, we know that we have our browser open and that we're at our application under test. And so the test case itself only needs to go through the actual flow of testing the application. Doesn't need to worry about opening browser, doesn't need to worry about getting to the test, it doesn't need to worry about closing the browser afterwards. And you can see this actually reads super nice and easy. Basically, like everyone can tell exactly what this stuff is doing, right? We're creating a new buy page, getting there from shopping item.buy an item for an apple. We can assert that we're actually buying an apple, and we can assert that the apple actually costs 89 cents. We can get to the confirmation page by going through the buy page and hitting submit. And then on the confirmation page, we can verify that we have purchased an apple and that we purchased it for 89 cents and that we can get the confirmation number to the logs. So in summation, we get all three of the things that we're after, right? We get our maintainability, we get our stability, we get our readability. And really, they're kind of gathered there. Page objects and good locators give us the maintainability. Again, the explicit waits and verifying page loads gives us our stability. And for readability, right, we want to follow those two rules. Page objects can either contain locators and they can contain action methods, not asserts. Tests can do asserts and they can make calls to page objects, but there's no Selenium commands in either one, and certainly no locators in our tests. Any questions? Still have some time. Yes?
So you said your page objects contain locators and methods?
Mm-hmm.
So you said your page objects contain locators and methods. A lot of sites have got common features, sections like headers and menu navs that would be repeated. Do you also have page objects within your page objects so you don't have to repeat that functionality?
Yeah, so organization of page objects is important, and structuring them so that you can organize them in such a way that shared functionality is going to get shared the right way. Is definitely a good thing. So you always want to favor composition over inheritance. So one thing that you could do is you could have, like, let's say you have a header nav that's across like every page, right? You could actually have an instance of the header nav composed in every page object. And then in that way, you can actually get to the navigation functionality from every page object. You're just going through that composition that you're adding to it. Good question. Yes, all the way in the back.
I agree with you on never using sleeps. The one exception, and I'd like your thoughts on this is that a lot of modern web pages now have animations that execute after a click. The element will be visible, but it takes an animation time to slide into view, and if you try to click it in advance of that, the click action will pass, but it won't navigate to the next page because it hasn't clicked at the right spot. So that's the one case where I would say, and I'm not sure what your thoughts are if you implement a custom method on the base page object that could be reused elsewhere, or if you do specific ones on the pages that have those animated elements.
Yeah, so I don't know that I've actually run into that particular scenario in any of the work that I've done with the company I'm at. I will say that this particular expected condition was chosen with great care, right? So we could have just as easily said, like, wait until the expected condition of like element to be displayed shows up, and then like work all of our stuff off of like, hey, if the element is displayed, then try to click it. But really, we went with the element to be clickable, or element, yeah, to be clickable is really like the element is not only displayed, but it's enabled and it's ready to go. And because of that, like, I'm not 100% sure if that would solve your problem, but that's about as good of an example as I can give based on my experience. Yes. Or, sorry, we got someone in the back first.
Somewhat related to his question is, in this case, your function is called isElementEnabled, but you're searching for it to be clickable. If in his case, clickable didn't work and it had to be displayed or something else because of an animation, and a team was wanting to introduce new functionality, how would you handle there essentially being two different functions in the same base page? Or would you expect them to introduce their own function that's very similar to this in their subclass?
Yeah, so we actually implemented a couple of different methods. So findElement is what like 99+% of like everyone ends up using, right? Because typically like you're always going to want the element to be enabled before you actually start using it. But there are some occasions where you just want it to be like displayed or present on the page, not necessarily enabled in order to use it. And for that, and for that, we actually created like findElement that is present as a separate method that you can use, which instead of, again, going through like the element is clickable, I forget what the exact expected condition is, but again, like expected conditions, there's a whole long list of them down deep in the Java code. So there's like element to be clickable, element is displayed, I think, or element is present within DOM or something like that. So you can do similar type methods. And again, note that like this method here is private. So like none of the page objects themselves are actually calling this thing. This thing is only really called from like things like findElement or click or is displayed or other methods that we might want to be able, we might want to bubble up functionality on. Does that answer your question? Okay. You can see me afterwards. We could discuss more. Looks like we got one down here and then one up there.
So in terms of the declaring the locators, I know you mentioned you chose to have by at the top of the page. Particular reason for not using the factory annotation there, like at find by and? Yeah, so by using the at find bys, we actually started out that way. And we run into the typical things that you run into with the page factory pattern, which is like you get stale element exceptions and no such element exceptions or stale element reference exceptions. By utilizing the bys, you could see like, whoops, where'd it go? You could see by utilizing the by locator itself, we're actually like finding the element and then at the very next line we do after we find the element is like interact with it, right? So we're never trying to find the element before we're doing something with it. So with the page factory pattern, right, you always have to call like page factory.init elements, and then like that's what's going to find everything. So it's going to like try to find everything all at once, and then like at some point, somewhere along the line, like you're going to try to use it down the road, but maybe the page has changed since then, or like something has happened since then. So by utilizing the by locators themselves, and then only finding the things in real time
like immediately before you want to interact with that specific element, that's what actually gets rid of the no such element exceptions and the stale element references as well.
So we shouldn't use the other one?
The page factory, I personally recommend against it. I don't want to tell like you what's best for like your particular situation. All I could say is from my own experience, like we started out that way and we noticed a bunch of problems and like we started going down the road of this implementation and like all of those problems seemed to go away for us. Yes, looks like we got one more question in the back and then I don't know if we're out of time.
Once you've established confidence in your tests and the frameworks, what's the next level that you go and look at when you experience flakiness?
I think I'll tell you when we get there. So a lot of the work that went into these slides, like I mentioned, I've been working at Vanguard for a number of years. The last 5 or 6, I've been working on basically like this framework, enhancing it, making it better, and like making changes to it. We've made a number of like pretty major changes over the years, and so even teams with the best intentions and that were actually following best practices 5 years ago, like those tests are not following the best practices that we have today because they've changed. So we are still in a pretty big backlog of like, not flaky tests, but like tests that need a lot of cleanup. And so we're still trying to work through them. But I will say that as of the last time that we made a fairly substantial change to our framework, which is about a year ago, any of the teams that have been using those newest standards, which is what all of these slides are based on, we haven't really seen any flakiness on. So that's really good news, and it'll be a matter of time to kind of like catch up the laggers from 5 or 6 years before until we're really there and ready to explore like what's next. Yeah, I think we got one more in the back there, and then we're out of time.
Just curious, do you have fail-fast mechanism in your test framework since you already spent time dealing with all kinds of exceptions? How do you leverage these exceptions you generate?
Yeah, so that's a good question. The way that we work most of our Selenium tests, at least right now at the company, we actually have a daily job that's completely outside of the build pipeline. There are a lot of reasons for that that kind of go into like the way that we deal with our builds and stuff like that and the way that we do our deployments. It's what worked best for us, at least at the time, and I think it'll probably change in the future. So really, we don't have any kind of like fail fast because the Selenium tests that we're running aren't actually a part of our build. So it's a matter of project teams paying attention to this extra build that they have that's going to give them the confidence to actually deploy their code. I think we're starting to go down this new CI/CD pipeline stuff. A lot of teams are writing protractor tests that are starting to run with their builds. And so we're going to be exploring that, I think, in the future. But for right now, it's basically everything's on its own separate build. So there's no real fail fast for it. All right, I think that's it. Thanks, everybody.
Okay, let's hear it for Craig.